Hi, today we're going to see the principle of fishery dynamics and management. One of the basic problems about the exploitations of renewable resources and fisheries in particular is that the fishing effort has increased dramatically since basically the motorization, the use of basically engines that are, fueled with fossil fuel, and has been increasing systematically, the capacity around the world. Just to give you an idea of the sheer size of the fishing effort, for instance, this is on your left. You can see here a satellite imagery of the squid fishery in front of Argentina. This is a picture that's been given by Wildlife Conservation Society and the Sea and Sky. And the amount of effort, the number of vessels that are fishing in the night by using light, it's so incredible that you can spot it from the satellite imagery. The sheer size of drift net, gill nets, purse, and pelagic longline has increased immensely thanks to more and more powerful engines. Bottom trolling nets are so big you could fit several 747 Boeing jet airplane inside the net. And you can see here the effect of trolling is one of the most destructive one on the species that are on the seafloor. And this is a video from Reef to Rubble by Oceana.org to just give you with the camera a sense of how these trawlers are basically raising the bottom. In addition to that, the average depth of fish caches has been increasing in the years thanks to geospatial tools and GPLs that allow to basically lay the nets with much more precision within the crevices and canyons that are present underwater. And the overall effect is overfishing, of course. It's the fact that we've been fishing too much. There is a long history of overexploitation that is represented here in this table. You can see with Antarctic, blue whales, fin whales, herring, the California sardine fisheries, the Peruvian fisheries, and so on and so forth. Like a sequence of fishery collapse one after the other. The Peruvian anchovy fishery is basically one of the sort of a textbook example of why, and how these happen. As you can see here, from 1959, after the collapse of the California fisheries, part of the fishing effort moved down in the south of the world to exploit the Peruvian anchovy fisheries. And you can see that the number of fishing boats has been increasing progressively through basically the 50 and the 60 to reach out and level off to about 1700s. At the same time, as you can see, the number of fishing days to reach the quotas that were set has been becoming, has increased. So they were being basically fishing for most of the year to decrease to a much shorter amount of the year. So they were able to catch a larger amount of quota. You see, basically here 10 million metric tons in a much shorter amount of time, basically rather than in 10 months, in just only 3 months. And so just to get a feeling of the sheer capacity until again there's been a collapse. We've been seeing at the beginning of the course the collapse of the sardine fishery in the Monterey Bay, and here is the anchovy fisheries has basically occurred. The same process, a combination of overexploitation and as well of unfavorable environmental conditions. It's another typical story we mentioned at the beginning of the course is in Newfoundland, the overfishing of the northern code, and again the same aspects. We see that the same movie, the fishing mortality increases at some point exponentially, recruitment start to decrease dramatically because of exploitation basically of the spawning stock. There are just many females that are contributing to reproduction until a dramatic collapse that you can see here of the fishery that was not only an ecological collapse but also an economic collapse for all the activities that were basically taking place and around this fishery. And in this other paper by Ransom Myers and Boris Worm, we see again that the vast majority of the cod and hake and monkfish fish around the Atlantic basically observe the same idea of looking at biomass dropping down while fishing mortality, basically going up. This is another really nice sketch that was presented years ago by Professor Jane Lubchenko that show how basically there is almost no spot around the world that where now we are in a post-peak phase. So it's been overexploited and now it is producing less than it used to produce some years ago. And we've seen that the global assessment of stock biomass support the conclusion that a remarkable fraction of the world fishery biodiversity is overexploited and depleted. The fractions has been consistently increasing even in recent years, and the recovery of depleted stock under intense management is still basically a real exception. But there is some good news because we start to see more successful cases of recovery. One of the difficult things, of course, is to document this systematic overfishing before collapse is actually, taking place. And, the remarkable reduction in fish size is certainly, one of the best indications. This was pretty clear already, for instance, during the big war, the World War I, when basically closures of the fisheries due to the war, was followed up by an increase in the abundance of top predators as well as on the size of the catch when the fisheries start to catch again when the end finish. But understanding what is the baseline is actually a very difficult job. There is a really nice paper on frontiers on ecology and the environment by Paolo Guidetti, who is a marine biologist and has just moved back to Italy, and Fiorenza Micheli, who is here at Stanford, the co-director of the Center for Ocean Solution and the co-director of the Hawking Marine Station, that have used basically historical hints like Roman and Greek mosaic to document a change in size and in the composition of the marine biodiversity that about 2,000 years ago, people in the Mediterranean Sea, was seeing and experiences. And there are other hints that can be used, and this is a beautiful paint by Giuseppe Arcimboldo, an Italian painter, who was using, basically biodiversity to represent beautiful paintings. And I think you might have seen those that have been using fruit, for instance, or game, terrestrial game. But this is one with marine species and provide a sense of what was on the table, in the Renaissance period, in the, some of the Italian noble family. The consequences of, these dramatic overexploitation of renewable resources, are start to become pretty clear. Well, first of all, there is a process that really prominent Canadian fishery biologist and fishery scientist Daniel Pauly, published in a seminal paper that is in fact titled "Fishing Down the Marine Food Webs," to indicate that the first species to go are usually those that are the larger size in the trophic web. And these are, as a cascading consequences on all basically the trophic web there that might be really relevant and are changing the way our ocean ecosystem are working. To summarize this short introduction that only touched some of the view problem, there are, fishery exploitation has direct impact, of course, on target species, especially when they tend to fish too much of them. With a reduction in fish size, a reduction in the amount of landing catch, might have a direct impact on non-target species, typically, for instance, in terms of bycatch, as represented here by, a sea lion that is being trapped in a fishing net. And then there are habitat damages, caused by dredging and indiscriminate bottom trawling that the Oceania video was documenting in a really direct, way, and also other indirect effects such as changing competitive outcomes, because we are changing the shape of the food webs and the trophic cascade, so the impact of removing top predators might have on the bottom species. The fundamental question is, why are we fishing so much? Why are we systematically fishing too much? And so this is going to be the topic of the next video.